Good morning, everyone, whoever is here right now. So Mrs. Goel has some problem with her internet or with her Zoom on her laptop right now. So I'll ask you guys to be patient, to wait for a couple of minutes for her to reset everything for you guys, okay? Thank you, guys.
Good morning, everyone. Sorry about the delay. My connection, I don't know what's going wrong with my laptop. Can you guys see my screen?
Yes.
Okay, thank you. So, good morning once again. Last time we completed chapter 3, just the last topic was left. And again, as I mentioned, 3.4, you will not be tested on 3.4, but we will go over 3.4 in the class. Before doing 3.4, let me just summarize what we did in chapter 3. And your homework was due on the weekend, but I extended the due dates for both homework and quiz, so you have enough time to work on it. And I noticed that most of you have already worked on your homework assignment at least once, so make sure you work on that. And another thing is, like, on Wednesday is a health and wellness day, so we will not have our Wednesday class meeting. So we are meeting today, and after today, we will be meeting on Friday. So we will not have class on Wednesday. And your homework assignment for chapter 3 and quiz for chapter 3 were due on Sunday, February 28th, but I extended both assignments. So make sure that you work on those assignments before our Friday class meeting, because today I'm planning to start chapter 4. But again, chapter 4 is a little long, so I will go over those concepts in Friday's meeting also. And but I'm thinking of opening chapter 4 assignments, so if you want to take a look, you can take those look. Take that chapter 4 lecture slide, homework, quiz, everything will be open this week. But again, nothing will be due until we cover everything in the class. So chapter 3, we talk about producing data. Anyone has any questions before I start about chapter 3 or in general? All right. So chapter 3, we talked about producing data, and then we talk about what is our available data, what is anecdotal data, what is experiment, what do we mean by observation study, how they are similar, how they are different. And then we also talked about sampling, and then we discuss simple random sampling. We talk about stratified sampling, multi-stage sampling, and systematic sampling. So we discuss all these 4 sampling designs, and we also talk about the examples, how we do simple random sampling, how we work with stratified or group sampling. And when we are talking about stratas or groups, we have the information about stratas and groups, and then we do the simple random sampling from these groups. And when we say stratified simple random sampling, we use simple random sampling. We do simple random sampling either using table B, using calculator, using technology, or like we mentioned that put all the sample, put the whole population in a box, label them, and then pick one at a time. And how do we do that? We do the chance process or randomization. So we do the random process. We talk about probability samples. And we say that probability sample, where we are talking about the chance process, every single subject is subject to chance, or you can say equally likely to get into the sample. Then we are talking about probability sample or randomization. We also discuss experimental design. And when we say experimental design, we are doing the experiments. And when you are doing the experiment, you are applying the treatment to the subject and then see if there is a cause and effect relationship or not. So when we are looking for cause and effect relationship, experiment are our only source of convincing data. Or you can say that when you need to see if there is a cause and effect, so apply the treatment. And let's say if I'm talking about 2 treatment, I apply those 2 treatment. And again, how, depending upon what my population is, then I'll take a sample for treatment 1 and sample for treatment 2. And again, how do we do sample? We learned that in sampling, we do simple random sampling. Simple random sampling, apply one treatment to one sample, another treatment to another sample, and then compare their results. So when we say experimental design, we talk about complete comparative randomized design. So again, randomized, where every subject has equal chance, or comparative when you do the comparison. And when you are talking about completely randomized design or completely randomized experiment, then you are applying treatment to the randomized. So take that as apply the treatment for the randomized selecting sample and then compare those results. When we talk about design, we talk about the principles of experimental design and 3 basic principles. The first one is control, randomize, and enough subject or repetition. So control, how do we control the effect of lurking or confounding variables? So when we talk about applying the treatment and then comparing the effect of those treatment, we do that to control the effect of lurking variable so that we do not have confounding. Randomize, again, you choose every single subject with a chance process. So every single subject has equal chance to get into the sample. And when we say enough subject, we need enough subject. Again, we will talk about how or what should be the sample size when we work with a particular population. But again, we need enough sample so that we can do repetition and then we can work with the experiment, or we can apply those treatments to the specific subjects. So these are the three principles of experimental design, and we talk about completely randomized design, block design, randomized block design, you can say that, and the third one we talk about matched pair design. So completely randomized, as I said, that first you need to know what is your population that you have to take the sample, and then how many treatments you have. So if you have one, two, you've had 2, 3, 4, 5, how many treatments? Let's say we have 4 treatments. Then I need to look for, first I need to make 4 groups, or you can say 4 simple randoms, 4 groups using simple random sampling. Let's say we have 45 students in this class and we are applying 4 different treatments to those 45 students. So I am going to do group 1, group 2, group 3, group 4, and applying 1 treatment to each group. Again, I don't know who is in group 1, who is in group 2, group 3, group 4, because when I am choosing group 1, I'm doing the simple random sampling out of these 45 to get into this group. And that can be the third label, 21, 43, any. So I can do simple random sampling, get 1 here, 1, 1, 1, and keep on doing until I get all 45 subjects in that. Once I have these 4 groups, then I can apply 1 treatment to each group, and then I compare all these. And that is called my completely randomized design. And the second one, we talk about block, randomized block design. And randomized block design, think of randomized block design as stratified sampling, because block is again strata or group, so that you know ahead of time. So when you are talking about block design, you know the blocks ahead of time. And let's say for our class, we are looking for the same example I'm using, how many freshmen we have, how many sophomore, how many junior, how many senior. So I will make a block using 4 groups, or I can say that I'm making 4 groups or 4 blocks, and this information is given to me ahead of time. So how many freshmen? There are 11, 15. And again, this information I know because when I go on Genie, I can see that how many students are freshmen, how many. So I'm not doing random sampling here. Again, this is the block that is given to me. And within each block, I can do the random sampling. And then from that random sampling, I can apply the treatments within each block. Let's say I'm working with 3 treatments. So I will make 3 groups within each block. And then I will assign these subjects in each block, in each group using simple random sampling. And then apply the treatment, how many I have, I'll make that many group, and then I'll do the comparison within each block. So in block, like how do we make block or how the blocks are made, that's something similar in some way. So when the blocks are given to us, we will look for how many treatments we have. Then we will divide the block into that many groups using simple random sampling, and then apply the treatment to each group, and then compare within each block. Same thing, I'll compare in this block, and this block. So this was block design, and the third one we talk about is matched pair design. And again, when we are saying matched pair, so we are talking about a pair. And when we are saying a pair has two subjects. So when I'm working with matched pair, I'm working with only two treatments. So when you're dividing the subjects into pairs, each pair has two subjects and each subject will get one treatment. Let's say we have 10 we are making match pair of 10. And again, match pair, we try to make match as closely as possible. And you can say twins, something, most of the things they have in common. So if we are talking about 10 and we make 5 match pairs, and each pair has two subjects. So for first pair, two subject, one, and each of them will get one treatment 1 and 2, and then compare. And let's say if I'm talking here about even number, but let's say if I have 9. So when I'm dividing these 9 subjects into pairs, I still will have 5 pairs. 4 pairs have 2 subjects and 1 pair has just 1 subject. When we are talking about just 1 subject, will this subject get treatment 1 or treatment 2? Because in match pair, we apply 2 treatments. So this subject will get both treatment, but we randomize the order of the treatment. If this subject will get treatment 2 first or treatment 1, so let's say it get treatment 2, and then later on the same subject will get treatment 1, and then you compare. We also talk about placebo effect. So effect of dummy treatment. And then we also talk about double-blind experiment. So when we are talking about double-blind, so we are saying neither the subject nor the people who come into the interaction with those subjects know who is getting the treatment or who is getting the placebo. So this is what we did so far in chapter 3, and your homework and quiz is based on that. So let me just quickly cover your last topic, which was when you do the sampling, what are the things you need to be careful when you work on the sampling? So ethics, basic data ethics, institutional review, board informed consent, confidentiality, clinic trials, behavior, and social experiment. The most complex issue of data ethics arises when we collect data from people. So when you're collecting data from people, you need to be careful about certain, or you can say a lot of things. So the organization that carries out the study must have an institutional review board that review all planned studies in advance in order to protect the subjects from possible harm. So when you are collecting the data, first of all, you need to take the approval from the institutional review board. And then what do institutional review board do? They review all the planned studies, and then they will see that there is no potential harm for the subjects, and then they pass that study that you can see. And, and now you have a child who is, I would say, a species. So I muted you all, but if you have any question, feel free to unmute and ask your questions. All individuals who are subject in a study must give their informed consent before the data is collected or the data are collected. So when you work on collecting the data, and again, when you are working on collecting the data from human being, you need to first make a consent form. And in that consent form, you mention what is your study about, what are the privacy and protection policy, why are you doing this, where, like, put all the information in that. And whoever is included in your survey, they need to find that consent form before you ask questions to them. So technically, you can think that they will give you a permission to conduct your survey on that. All individual data must be kept confidential. And again, this is very important. Only statistical summaries of group of subject may be made public. So when you collect the data, what's the first thing you do? That first, once you collect the data, you remove the identity from the data and just work with that data set so that their data or their privacy is protected. So only statistical summary for groups of subjects may be made public, not their names or other private information. Institutional Review Board, the organization that carries out the study must have an institutional review board that review or plan studies in advance in order to protect the subject from possible harm that we just learned in the previous slide. And what is their purpose is to protect the right and welfare of human subjects, including patients. And again, we collect a lot of data on the patient, on the research, on the ongoing study, and recruited to participate in the research activities. The institutional review reviews the plan of study. Not necessary that what your plan of study and what you are doing, they are fully convinced. They may do some changes depending upon what your study is including. Is there a potential harm for to the subject from your study? So they may or may not suggest some changes to your study. And then they also review the consent form. So once you are done making the consent form, then you send that consent form to review board, and then they will see if that consent form has every single thing included, or you need to further add more stuff to that. And then monitor progress at least once a year. Informed consent, who should you give the informed consent, or who should not be considered in your survey, or who you should not ask questions or give the consent form. All subjects must give their informed consent before data are collected. Subject must be informed in advance about the nature of a study and any risk or harm it may bring. Subject must then consent in writing. And again, consent in writing means the consent form is given to them. They need to read, and then they need to do their signature to confirm that we read the information and we are doing it willingly, and we know what this study is about and what type of data is collected. Who cannot give consent form? Again, the very young children, prisoners, and people with mental disorders. These should not be considered in your consent form, or who cannot give consents. Confidentiality, the important part when you work with the sampling or when you work with producing or collecting the data. All individual data must be kept confidential. So you cannot discuss, you cannot share with that. You can collect the data and then remove the identity and work with that data. Only statistical summaries may be made public. Confidentiality is not the same as anonymity. Again, anonymity and confidentiality are two different terms. Anonymity prevents follow-up to decrease non-response or inform subjects of results. But confidentiality to keep everything confidential or to keep everything separate, not to be appeared in public. Separate the identity of the subject from the rest of the data immediately. So again, you collect the data. Once your data is collected, that is the important part, so that you can create confidentiality, because now you don't know this data is coming from where, and you have the data set, then work with the data set. You do not need the name or address or other information for that. Okay, clinical trials, and now we all know that clinical trials for COVID vaccine was going on since last year, and we had some results. We had some positive, or you can say some vaccines already in the market, and some are still under the trial phase 1, 2, 3. And again, we do all that when we collect the sample and then we work on that. Clinical trial study the effectiveness of medical treatment on actual patients, and these treatment can harm as well as heal because they are clinical trials. We do not know if that will work or not. Points for a discussion: randomized comparative experiments are the only way to see the true effect of new treatment. Why? Because we need to see the effect or the cause and effect relationship. So again, when we are looking for the cause and effect relationship, if we apply this treatment, will we get some results, positive or negative? What kind of results? Then we are talking about experiments. And again, randomized comparative experiment. When we are saying randomized, again, we are giving every single chance. So every equally likely, or everybody get a chance getting into the sample. Then we are comparing. When we apply the treatment experiment, you apply the treatment, and then you compare those treatment. And who, when you do the randomized sample. Most benefit of clinical trial go to the future patients. We must balance future patient against present risk. The interest of the subject must always prevail over the interest of science and society. So this should be important. Behavior of social sciences, and again, behavior and social science experiment. Many behavior experiment rely on hiding the true purpose of the study. Subject would change their behavior if you told in advance. Investigators were looking for. So again, when we apply the treatment, we also apply the placebo so that the subject does not know if that subject is getting the real treatment or the dummy treatment, and then they can give, or you can say that then you will see when you compare if there is a cause and effect relationship or not. The ethical principle of American Psychology Association require consent unless the study merely observe behavior in public space. So again, where you are collecting the data, you need to look for all the information, or you can say you need to look for all the possible scenarios or all the situations or all the paperwork, every single thing before you collect the survey. So collecting the survey or collecting the sample is not as easy that you just go and collect. But again, you need to follow certain guidelines, certain rules and regulation, and then you can work with that. So our PhD students in sample survey class, we offer a complete course, as I mentioned, sample survey, sampling survey methods. Or so this we have a course for our PhD and master students. So they collect the survey, and when we have face-to-face class, they come during our class time and they talk about what survey they are doing. They give you a consent form, and then again, I can say that this is kind of practical experience, like what they are doing actually, what we are learning here in the slides or in the book. But that is like first-hand experience we get when they come to our class. They talk about their study, they give their consent form, and then they actually ask you questions. And there are different ways of asking the questions. Some are face-to-face, some on a deck of a card, and there are different ways. So one of our PhD students is collecting or he is doing a survey, and he's collecting the sample from all stat classes. So I will send that information on Canvas to all of you. Read that information. And again, since that student cannot come to every single student, so consent form is not handwritten where you have to sign, but some information is provided. So feel free to participate in that survey. And again, you can open the survey, and then you can see that if you feel comfortable asking those questions, then ask. And again, confidentiality is important, so your none of your information will be provided to him or her. It's just what the question that person is asking, you need to give that. And again, he will, once he will get the response, he will again look at is hers or his survey suffering from non-response or under-coverage or response bias. So he will look at everything. And again, if he need a sample of size, let's say 100, he is starting from a sample of size 200 or 300 because he knows or she knows that there will be a lot of other things that they need to be careful. So I will send that information on Canvas, and if you have time, please do that. So that ends our chapter 3. Any questions about chapter 3? Okay, if not, let's talk about chapter 4. So your test 2 will be on chapter 3 and chapter 4. So we completed chapter 3. And as I discussed in the last class, that on your schedule there were some date confusion, so I fixed those dates and extended your chapter 3 homework assignment. And chapter 4 assignments will be open, but nothing will be due this week because we will not have class on Wednesday. We will have class on Friday, though. All right. So, chapter 4, we are talking about probability, the study of randomness. And we discuss or we talk about this little bit of this in chapter 3. So, again, we are talking about randomness. We are talking about chance process. And we are talking about equally likely. So, when we are talking about probability, again, we all heard about probability, that what is the chance of getting this, or what is the chance of getting into the sample out of a size of 45 population. So, how, when we are talking about probability, we call it as a random phenomena. Or you can say that probability of, when we are talking about probability of random phenomena, or you can say is the proportion of times the outcome would occur in a very long series of repetition. So when we talk about probability, we say that probability is a long-term phenomenon. And what does that mean? So let's say if I toss a coin, so when I toss a coin, I know that I will either get a head or a tail. I will not get both. So when I'm tossing a coin, I know that either I get a head or a tail. So we can say that, not head, we'll get a head and a tail. And when we say that we get a head or a tail, the chances are 50% or 50% or half and half. And we say that probability of getting a head is half and probability of getting a tail is half. So that's what we know about the probability. So when we are saying probability, let's say that random experiment. So you are doing a random experiment, or let's say tossing the same coin. So we get a head and tail. So when we are doing a random experiment is where the outcomes are subject to chance. And when we are saying subject to chance, it can be either a head or a tail. So we know that there are predictable outcomes. And that predictable outcome can be either a head or a tail. But we don't know if it's a head in the first toss or it's a tail. So there is some uncertainty that is associated with it. So when we are talking about random experiment, we are talking about an experiment that is where we are talking about a chance process. And in random experiment, we get predictable outcomes because we know when we toss a coin, we can get a head or a tail. We will not get anything other than head or a tail until unless the coin is stand up and it's neither a head or a tail. And I'm talking about a balanced coin. Then the chances are 50-50. So when we are talking about random experiment, we are getting predictable outcomes. But again, we do not know which outcome we get, either a head or a tail. Same thing, when you roll a die, you will get either 1, 2, 3, 4, 5, 6. So when you roll a die, these are the possible outcomes that you get. But you do not know, so this is my predictable outcome. And uncertainty is, I don't know on my first trial when I roll, will I get a 4 or a 5 or a 3 or a 2? Or when I roll, maybe I get 4 on the first trial, second time also 4, then 3, then 1. So I know that I will get something out of this. but I don't know what I get. Same thing, when we toss a coin one time, we know that the chances are 50-50. If I toss a coin again, do you think if I get a head in my first trial, will I get the head in the second trial? For sure. Or a tail?
No.
No, because again, we say that we know what we get, either a head or a tail, but we do not know the order. Will we get a head or tail? So in one trial, I get 50-50% chance head or head. So when I toss it again, I may not get a head, maybe a tail. Next time, head, maybe head, tail, and keep on going. So now the chances are not 50-50. The chances are different depending upon how many trials I'm doing. But when I toss a coin, let's say I've tossed this coin 10 times, and on the basis of this result, can I say that I will get exactly 5 heads and 5 tails?
No.
No, maybe, but most maybe not. Same thing if I toss it 100 times. Can I say 500 head, 500 tail? Again, the answer is no. So when you do it 1,000 times or 10,000 or 20,000 or 50,000, then you will start seeing that when you do it for the longer time, you will see that the outcomes are close to 50-50. And again, I'm not saying 50 exact, close to 50-50. Let's say you toss it for 1,000 times and you got 475 times head and 525 times tail, and same thing 10,000, 20,000. So when we say probability is a long-term process or long-term phenomena, we are talking about when we keep on repeating the trials for a long time, we will see that the processes, or you can say that the outcomes are close to 50-50. So probability, when we talk about probability, we talk about the long term. We cannot say the same when we are tossing a coin 4 times or 10 times or 50 times. So that's why we keep on repeating the experiment, or we keep on doing the trials. And again, we do not do it manually. If I tell you to toss a coin 10,000 times, that's your project is toss a coin 10,000 times and tell me exactly how many head, how many tail you do. Again, we are not doing it manually. It will take so long. So we do simulations, we do some kind of software, and we'll say we are tossing it and how many heads and how many tails. And then you get that. And then again, when we are talking about probability, we know what kind of outcome we get. We just don't know the order. But when we keep on repeating the trials, we will see the outcome is likely to be close to half and half or 50-50. So let me just go with the slides, how much time we have. Okay. So chapter 4, we will talk about randomness, probability models, random variable, mean and variance of random variables, and general probability rules. And these general probability rules are given towards the end, but I will introduce these rules in the beginning so that you know what general probability rules are and how do we follow these rules when we talk about different kind of events or when we are working with different probability models. There are 2 homework assignments on chapter 4. So instead of making a one big assignment, I split it into 2 homework assignments. So there are 2 homework assignments on chapter 4, but there will be one quiz. And chapter 4, again, as I mentioned, it is very important because it talks about both numerical as well as a conceptual questions in chapter 4, homework and quiz. Chapter 3, we see that it's mostly conceptual, but chapter 4, you will do some numerical questions also. But again, if the theory behind it is clear, or I can say the concept behind probability or probability models or rules is clear, then this chapter is not hard. So the language of probability, we just talked. So let's just read in the slide what they have for us. Chance behavior is unpredictable in the short run, but has a regular and predictable pattern in the long run that we just discussed. And the example is given here. We call a phenomena random if individual outcomes are uncertain, but they have a regular distribution of outcomes in a large number of repetition. When you toss a coin 5 times, you don't know the chance of getting a head and tail is still 50-50 or not. But when you keep on tossing and you keep on repeating, and in the long run, you see the outcomes will have a regular pattern. The probability of an outcome of a random phenomena is the proportion of times the outcome will occur in a very long series of repetition. And again, you can see that you toss one coin, two, you keep on doing, and then after some point, you will see that it will close to 50-50. So it goes up and down, you can see that, but after certain time, it will be, you can see a regular pattern. Thinking about the randomness, we just talked about this. The result of any single toss is random, but the results over many tosses is predictable as long as the trials are independent. And we will talk about this independent, and it's a very important topic. And again, we talk about independent variable in chapter 2. And again, when we are independent. So that means not dependent, right? So we talk about explanatory variable X is independent of the response variable. So when we say independent variable, independent, we are going to talk about events in this chapter, and we will say independent events. When what does independent actually means? That means you toss a coin and you get a head in the first trial. So if I toss a coin and I get a head in the first trial, and I toss a coin again, so knowing that I have head in my first trial, it's not going to affect of chances of my getting a head or a tail in the second trial. So that means they are independent of each other. So the probability of one is not going to affect the chances of happening your second event again. So those two events are called independent events. So you toss a coin, you get a head. When you toss it again, knowing that I have head here, is it going to change the outcome of my second trial? No, it can still be a head or a tail. So these two are independent of each other. And the definition is also given here. That is, the outcome of a new coin flip is not influenced by the result of your previous flip. So knowing the chance of happening one is not going to affect the chances of happening your second event. And those are called independent events. Uses of probability. Again, we use probability in different fields, and some are provided here. The origin of probability was 17th century games of chance. In the 18th and 19th century, carefully measurement in astronomy surveying led to further advance in probability due to the distribution that arises from random sampling. And again, here we are using probability or the chance process. Probability models. And again, I think currently hot topic is share market. Going up and down, fluctuating every single day. And again, probability plays an important role, chance, and how they are going up, down, where they will stay. Okay, so probability models. When we talk about probability model, first of all, what actually probability model is. So when we are talking about probability, we talk about few things. First, probability. First thing is we say sample space. Event. I think they have it here. So description of the chance behavior consists of two parts, a list of possible outcomes and a probability of each outcome. And using the same example, you toss a coin, you get head and tail. So if I get head and tail, these are my possible outcomes. So I can say that my outcomes are, and this is called my sample space. The list of all possible outcomes. And now, what is the chance of getting ahead? And I know that the chance of getting ahead is how many outcomes I have? 2. And out of those 2, head is 1 out of 2. Same thing, tail is 1 out of 2. So the probability of getting ahead is 1/2 if I put probability in terms of, and we can call it as a H or T, or we will talk about event if we are looking for particular event, and that event is probability of getting ahead is 1/2. Probability of getting a tail is 1/2. So sample space is the set of all possible outcome. Random phenomena is the set of all possible outcome, all the outcomes that you can have, and we denote it with uppercase case S. So S is the set of all possible outcomes. You roll a die here. When you roll this die, what is your sample space? So here you're rolling 2 die. So let's just talk about rolling 1 die. So when we roll 1 die, we can get either 1, 2, 3, 4, 5, 6. So this is my sample space. What is the probability of getting a head? The probability of getting a 5. First of all, I need to know the probability of each of them. How many outcomes are there? 6. What is the probability of getting 1? 1/6. Same thing, 1/6. All of them has 1/6 chance, right? So the probability or the chance of getting each outcome is 1 out of 6. And what is the probability of getting 5? 1/6. And if I'm saying what is the probability of getting greater than equal to 3? Let's say x is greater than equal to 3. What is the probability of getting the number greater than equal to 3? So greater than equal to 3 is this. 3 is included because I see equal sign. Greater than equal to 3, first of all, I'll see the event that has greater than equal to 3, 3, 4, 5, 6. And I know their individual probabilities, 1/6, 1/6. So probability is 4 out of 6 or 2 out of 3. Same thing, we can do what is the probability between 1 and 3 or 2 and 4. So you can create as many events as you can from the same sample space. Questions? So an event is an outcome or a set of outcomes of a random phenomena. That is, an event is a subset of sample space. And what is a subset? Subset is a set or a small set from this big sample space. So event is always, it is a subset of this. Sample space, big set you can think. And an event, a subset of this, a small part. Or apart from this is your event. So event always come from your sample space, and sample space has all the outcomes. Event can have all, some, 1, 2, 3, depending upon what you are creating. A probability model is a description of some random phenomena that consists of 2 parts. One is your sample space and another is a probability of each outcome. So you can think of probability model needs 2 things. One is your sample space and one is your event. An event will give you the probability of each outcome. And again, once you know your sample space, then you can find the probability of an event, because sample space will give you the individual probability of each outcome. If we do not know there are 6 outcomes, we cannot find the probability of this or this or this or this or this. So when we talk about the set of possible outcomes that we can count, then we call it as discrete probability model. So when you can count the set of possible outcomes, we are talking about discrete probability models. And then we will also talk about continuous probability model. And when we are saying continuous probability model, that means we are using the same concept we learned in chapter 1 when we are talking about the area under the curve, and we are talking about what is the probability between this and this, or from here to here. So when we are talking about here to here, that means we are talking about the area under the curve. So when we are talking about this, then we are talking about continuous probability model. And continuous probability model, you cannot find the probability of an individual outcome. You can find the probability from here to here, but you cannot find at this point or this point. So we will talk about this more in detail in our Friday's class. So I will stop here. Thank you, everyone. I hope you all will get some rest on Wednesday, and I'll see you guys on Friday. Thank you, everyone.
Thank you.
Monica,
Yes.
are we getting back in 10 minutes?
Yeah, that would be great.
Okay.
Yeah,
All right.
I'll see you.
See you soon.
I have not done much though.
It's okay. Me either.
It's so frustrating.
I know. But we'll talk later.
Okay.
In
All
10
right.
minutes.
See you.
See you.